Hi everybody, I'm Miss Cooksey. Today we're going to talk about evaluating functions. So in our last lesson, we learned what a function is. A function is a special kind of relation in which every input has exactly one output, or every x value has exactly one y value. When we have an equation that is a function, we write it using something called function notation. And that tells whoever's looking at the equation that this is a function and that whatever the input is will give me a one specific output. So if I have this equation, y equals 3x minus 4, and I would like to write it in function notation to tell me that this is a function, I'm going to write it as f of x equals 3x minus 4. Notice that the only thing that changes when we move this to function notation is that y turns into this f of x. So the first thing to note is that this is read as f of x, not fx, not f parentheses x, f of x, which means the function of x. It also is important to note that this is not multiplication. What a lot of people want to do when they see this is we think, oh, we're in math, we see parentheses, we should multiply. That is not true for function notation. This is not multiplication. What this tells us is that whatever I input for x, whatever I place into these parentheses, will give me a specific output. So imagine that these parentheses are actually just like a big tube, and we're going to place a number in for x, and then out on the other end of the machine is going to pop out some sort of output. We're going to look at a bunch of examples and how we use this function notation to evaluate functions. So here is our prompt. Evaluate if f of x equals 3x minus 4 and g of x equals 2x squared minus 3x. So we're going to start with f of 2. The way we evaluate this is we are going to take what our equation is for x, so f of x equals 3x minus 4, and we're going to substitute in 2 because f of 2 tells me that I replace x with 2. So f of 2 equals 3 times 2 minus 4. So I took this function and I replaced x with 2. Now I'm going to use order of operations to evaluate this. So 3 times 2 is 6, minus 4 is 2. This tells us that f of 2 equals 2. So what this means in human speak is that when x equals 2, so when I input 2 into my parentheses, then y equals 2, which is the result once we evaluate. Let's look at another example. In our next example, we have g of 4. So here we're going to take this g of x equals 2x squared minus 3x, and we're going to substitute in 4. G of 4 equals 2 times 4 squared minus 3 times 4. I took this function and I substituted in 4. Now we'll use order of operations. So we're going to start with 4 squared. So 4 squared is 16. I went ahead and did 3 times 4, which is 12. 2 times 16 is 32. Minus 12 is 20. So in human speak, this means when x equals 4, when I input 4, y equals 20. I output 20. In my next example, it's going to work the same way. I'm going to take that same f of x equals 3x minus 4. This time I'm going to substitute in negative 3. So f of negative 3 equals 3 times negative 3 minus 4. F of negative 3 equals negative 9 minus 4. F of negative 3 equals negative 13. So when x equals negative 3, y equals negative 13. For g of negative 4, we are going to take our g function, g of x, which equals 2x squared minus 3x, and we're going to substitute in. So g of negative 4 equals 2 times negative 4 squared minus 3 times negative 4. That gives us 2 times 16 plus 12. Something to notice is that negative 4 squared is a positive 16 because negative 4 times negative 4 is positive 16. So now I'm going to multiply. 2 times 16 is 32 plus 12 is 44. So when x equals negative 4, y equals 44. My last two examples are a little bit different, and so I really want to make sure that we understand how these two examples work. So here I have f of x equals 5. In these examples, I'm actually solving for x. So previously I was given x, now I'm solving for x. So I'm going to take this same function, f of x equals 3x minus 4, and I'm going to replace the whole of f of x with 5 because I'm told that f of x equals 5. So 3x minus 4 equals 5. Then I can solve by adding 4 on both sides, dividing by 3, and I get x equals 3. This tells me, that is the wrong number written there, that when y equals 5, x equals 3. Last but not least, we're going to do the same thing here. F of x equals negative 4. Well, we know f of x equals negative 4, so we're going to replace the whole of f of x with negative 4. So 3x minus 4 equals negative 4. 3x, we add 4 on both sides, then divide by 3, and x equals 0. So this tells us in human speak that when y equals negative 4, x equals 0. So in this video, we learned how to evaluate a function. So we learned what function notation is. Function notation is when I replace y with f of x to tell us that this, for every input, we have one specific output. We read this f of x as f of x, and it is not multiplication. And we learned how when we're giving something in function notation like f of 2, we can use that to evaluate a function. Thanks for watching. I hope this was helpful. Make sure to subscribe if you're in my class so you never miss a video, and see you next time.